high above the earth, hidden beyond the velvet black of night, a giant burns. We call it the sun. To most of us, it feels ordinary, just another part of daily life. It rises each morning, it sets each evening, it warms our skin and brightens the sky. But have you ever paused to wonder whether it is as safe as it seems? Could that golden light we trust so much be hiding something far more powerful, far more dangerous than we imagine? What keeps the sun burning so endlessly? How much longer can it last? And what happens when its balance falters, when it grows too strong, too unstable, too violent? Could it be that the same star that gives us life also holds the power to end it? For thousands of years, humans trusted the sun without question. Ancient civilizations built temples aligned with its rise, prayed for its return after the long dark of winter, and celebrated its peak at midsummer. But they also feared it. Why? Did they sense, even then, that behind its warmth was something untamed? Could their myths of fiery gods and raging suns have been early echoes of truths we're only now uncovering? Each morning, when sunlight brushes your face, it feels soft and comforting. But have you ever thought about how close we live to fire? Just the right distance keeps us alive. A little closer, and the seas would boil. A little farther, and the oceans would freeze. The balance that sustains us is so fragile, it's almost unsettling. The sun is not solid. It's not calm. It's not gentle. It's a storm, an endless ocean of plasma, boiling and erupting without pause. Arcs of flame rise higher than Earth itself, looping across its surface before crashing back. Dark sunspots appear and vanish, scars of tangled magnetic force. And when that force snaps, what follows? That's when we see solar flares. Imagine a flash brighter than the sun itself, lasting only moments, yet carrying the energy of billions of bombs. These flares race across space at the speed of light, reaching Earth in minutes. They rattle the upper atmosphere, bend our protective shield, and scramble communications. Could a single flare silence satellites worldwide? Could it blind pilots in midair or disrupt submarines deep beneath the seas? But flares are only part of the danger. Sometimes the sun hurls not just light, but matter itself. Massive clouds of charged particles blasted outward at terrifying speeds. These are coronal mass ejections, or CMES. Slower than light, but no less destructive, they slam into Earth's magnetic field, shaking it, twisting it, bending it. And when that shield bends, what happens beneath it? We see the evidence as auroras. Curtains of green and red light ripple across polar skies, breathtakingly beautiful. But what do those lights really mean? They are not just decoration. They are proof of a cosmic battle between Earth and the Sun. Evidence that our planet is under attack and that its defenses are holding. What if one night those glowing curtains stretched across the entire world, not just the poles? Would we still call them beautiful? Or would we recognize them as warnings? History has already shown us what's possible. In 1859, a flare so powerful struck Earth that it set telegraph wires ablaze. Papers caught fire. Operators were shocked by currents that surged through their machines. And the skies glowed so brightly that newspapers could be read at midnight beneath shimmering auroras. That storm is remembered as the Carrington Event. If it had happened in our age of satellites and electricity, what would the world look like now? Could modern grids withstand it? Could planes stay in the sky? Could hospitals keep their lights on? Imagine waking to silence. No signal, no internet, no electricity. Entire cities darkened. Banks without records. Governments cut off. Trains halted. Planes grounded. How long could we endure such silence? Days? Weeks? Months? Could our society unravel? Not because of war or famine, but because the sun decided to send a storm? And these storms are not just history. In 1989, Quebec's power grid collapsed in 90 seconds after a geomagnetic storm. Millions were left in darkness. Transformers burned. Satellites faltered. And that storm was nowhere near as strong as the Carrington Event. What if something greater came tomorrow? What if something beyond anything in recorded history struck us? Could we recover? Or would we slip backward, struggling in the dark? The sun's moods follow rhythms. Roughly every 11 years, its activity rises and falls. At its peaks, storms are more frequent. Scientists track these cycles, watching its surface for signs of unrest, sending warnings when something dangerous is heading our way. But even with all their vigilance, can we really prepare? Can machines built by human hands withstand the breath of a star? Have you ever thought about how fragile our world truly is? We treat satellites as untouchable, but they're delicate shells of metal, easily crippled by radiation. We imagine our power grids as stable, yet they can collapse in seconds under the strain of solar currents. We think of communication as permanent, but it could vanish with a single storm. Could it be that civilization's greatest vulnerability is not on Earth at all, but in the sky above us? And then comes the question we can't ignore. What if the sun is capable of even more than we've seen? Astronomers studying distant stars have found superflares, eruptions hundreds of times more powerful than anything our sun has shown us. Could our sun unleash one, too? What if it happened tomorrow? Could Earth endure it? Or would our story end in a silent flash, erased by the fury of our own star? The unsettling truth is that we don't know. The sun has surprised us before. It will surprise us again. We can measure its rhythms, watch its storms, study its cycles. But we cannot predict everything it may do. We cannot control it. We cannot escape it. We can only endure it. And yet, for all its danger, the sun remains beautiful. Think of a sunrise again. The first glow at the horizon, the pale gold spilling into the sky, shadows stretching, then retreating, the world awakening. The same fire that threatens us also nurtures us. It stirs the winds, it drives the seas, it feeds the forests. Without it, could we breathe? Could we eat? Could we dream? The answer is no. We are bound to it, in life and in death. So how should we feel, knowing all this? Should we fear the sun, knowing it hides storms capable of silencing our world? Should we revere it, grateful for every moment of warmth? Should we prepare for the day it turns against us? Or should we simply cherish it, thankful for each dawn, each golden afternoon, each crimson sunset? The sun is both truth and mystery, both friend and threat, both comfort and terror. And tonight, we step into its shadows. We'll follow its hidden story, its storms, its dangers, its inevitable future. We'll see the dark truths that lie beneath the fire. As you close your eyes and let this story carry you, keep the questions close. What if the next great storm comes tomorrow? What if the sun isn't as steady as we believe? What if the light we trust hides shadows we have yet to see? The sun burns. It always has. It always will, until it doesn't. And within that truth lies the greatest mystery of all. And so, the story begins. When you look up at the sun, it seems perfectly behaved, round, steady, the same bright coin in the sky. That calm is easy to trust, but it hides a chaos you can't see from the ground. The sun's surface is an active place. Enormous loops of glowing gas lift and fall. Dark patches appear and vanish, and magnetic fields twist like knots. is an ocean of hot plasma, always moving, always restless. When the pressure of those magnetic knots releases, the sun flares. A flare is a sudden, violent burst of light and radiation. It is not a slow, gentle thing. It's a sharp, blinding crack of energy. And though it lasts a short time, the impact reaches far. Imagine that flash sweeping across space at the speed of light, reaching us in minutes. That invisible wave bangs into the upper reaches of Earth's atmosphere and tugs at the bubble we call the magnetosphere, the magnetic shield that protects us. Radios stutter. Navigation signals bend. High-frequency transmissions go noisy. It's the sort of disruption pilots or ship captains would notice first, small and dangerous in equal measure. Could one such flare make your phone useless for hours? Could it interfere with the very systems that guide planes at night? These are not dramatic hypotheticals. They are real-world outcomes of a star doing what stars do. Then there are coronal mass ejections, or CMES, which are like the sun coughing out a cloud of charged particles. A CME doesn't move at light speed, but it travels fast enough, millions of kilometers per hour. And when it catches up with Earth, it slams into that same magnetic shield. The result can be dramatic. The magnetosphere compresses. Electric currents surge through the upper atmosphere and by induction through metal on the ground. Long pipelines and power lines can suddenly carry enormous currents. Transformers, the heart of any electrical grid, can overheat and fail. Do you see how fragile our system is when an invisible storm overhead can find its way into the wires that power your street? Look at the sky sometimes, and you might see auroras, those shimmering curtains of green, purple, and red near the poles. They are astonishingly beautiful, and people travel great distances just to stand beneath them. But they are also the visible signature of a sun-to-earth electrical storm. Particles from a CME collide with atoms in the atmosphere, energizing them and producing color. The sight is gorgeous, but it is the public face of something that can be dangerous if it grows strong enough. What if one night those curtains spread much farther south, lighting up skies over cities that never expected to see such sights? Would we marvel and then panic? Or would the beauty make us forget the risk for a moment before reality returned? History gives a chilling example. In September 1859, a solar storm, now known as the Carrington Event, arrived with such force that telegraph systems, then the world's most advanced communications technology, caught fire. Telegraph operators were shocked. Sparks jumped from the apparatus. Reports say some operators were able to send messages even after disconnecting their batteries, powered only by currents induced in the lines by the storm. The auroras from that storm were seen as far south as Cuba. That was a world with no satellites, no power grid as we know it, no internet. What would the Carrington Event do to us today, with tens of thousands of satellites in orbit, GPS guiding nearly everything from freight ships to farm tractors, and data centers humming 24/7 across the globe? Picture a morning in which, all at once, dozens of satellites falter. GPS coordinates flicker and fail, leaving planes and ships scrambling to rely on other instruments. Cell towers lose synchronization as power surges, fry transformers, and whole regions go dark. For a few days, perhaps weeks, communications could be patchy. Air traffic could be grounded for safety. The systems we depend on, financial exchanges, emergency services, supply chain logistics, might slow or stop. How long could a modern city manage without steady electricity and reliable communications? Would grocery stores have supplies? Could hospitals run only on battery backups? These are not distant science fiction scenes. They are scenarios governments and utilities around the world take seriously when space weather warnings come. We've felt the teeth of the sun in more recent times. In March 1989, a geomagnetic storm collapsed the Hydro-Quebec electrical grid, leaving 6 million people without power for 9 hours. It took many days to fully restore certain systems, and some equipment was permanently damaged. That was a severe but not extreme storm. It was a warning. What if the next event is stronger? What if a storm similar to Carrington hits at a time when the grid is already stressed by other factors, heat waves, cyber attacks, or political upheaval? The compound risk becomes far harder to manage. Scientists now monitor the sun constantly. There are space-based observatories that keep it under near continuous watch, measuring magnetic fields, watching for sunspots where flares tend to originate, and calculating the trajectory of charged clouds. When a flare erupts, they can often give early warning, minutes for the flare's wavefront, hours for a CME. Those hours matter. Utilities can take transformers offline, reroute power, pause sensitive operations. Astronauts can move to shielded areas. Airlines can reroute flights away from high-latitude routes more exposed to radiation. But early warning is different from prevention. We can prepare, but we cannot prevent the sun from acting. That gap between warning and control is where anxiety sits. We have no planetary scale foolproof shield that blocks everything. We have clever engineers and practical fixes, and in many cases, those are good enough. But the systems of modern life are also interconnected in ways that create cascading failure modes. One failing node can ripple through supply chains, financial systems, health services. If satellites fail, the ripple is enormous. Everything from international money transfers to temperature forecasts would be affected. The invisible dependencies are staggering. Most of them are things we don't notice until they stop working. There are other uncertainties, too. Astronomers observing other stars have seen superflares, eruptions that dwarf what our sun has shown. While our sun is less active than some of those stars, we can't be entirely sure it won't surprise us. A superflare would be orders of magnitude more powerful than the Carrington Event. If such an eruption struck Earth, it could strip away parts of the atmosphere, burst through electronics, and produce radiation levels that are dangerous for satellites and astronauts. Could life survive being hit by such a blast? Perhaps. Perhaps not. The question is sobering because we base modern civilization on fragile technology and just-in-time systems that assume continuity. Because of these real risks, governments and industries plan for space weather. Power companies test how to isolate and protect critical transformers. Satellite operators build redundancy into fleets. And some put extra shielding into particularly important hardware. National space agencies coordinate warnings across borders. But there are limits. Shielding adds weight and cost. Redundancy adds expense. And policy decisions must balance risk, budget, and immediate needs. Those choices are human and sometimes fallible. What if international coordination breaks down in a crisis? What if a powerful storm comes at a politically tense moment? The social and political dimensions of solar storm impacts are part of the whole equation. Beyond infrastructure, the sun's storms have subtler effects. High-energy particles can alter the chemistry of the upper atmosphere in ways that affect radio propagation, which in turn affects navigation and communications. Wildlife that uses Earth's magnetic field, migratory birds, sea turtles, some fish, may find their internal compasses confused during strong geomagnetic disturbances. These biological side effects are less dramatic than burning transformers, but they show how interconnected life on Earth is with solar activity. We are not separate from the star. We are partners in a conversation we barely control. The sun's temper is also cyclical. Its magnetic activity waxes and wanes in roughly 11-year cycles. At solar maximum, the surface seethes, sunspots cluster, flares become more frequent, CMEs follow with greater regularity. Scientists have become adept at watching these patterns and projecting the rough shape of the next solar cycle. Still, the details matter. A single, unusually strong eruption within a cycle can be the difference between a manageable event and a catastrophic one. So the question remains, are we prepared? In many ways, yes. In many ways, no. The grid and satellite operators have better tools now than a few decades ago. We can forecast, and that helps. But forecasts do not stop molten plasma from traveling across the void. They don't guarantee that every transformer will be protected, that every vulnerable satellite will be safe, that every patient-dependent device in a hospital has the backup it needs when the grid blinks out. Preparation reduces risk, but it does not eliminate it. This is why the sun's story is both practical and existential. It's about circuits and satellites and supply chains, yes. But it's also about the fragile thread of human civilization tensioned against forces far older and larger than us. Space weather is a reminder of scale. It forces us to confront how much of what we rely on sits outside our control. That realization can feel unsettling, yet there is a kind of clarity in it, too. We are part of a dynamic system, alive to the push and pull of a living star. When the auroras flare bright, when instruments on satellites record a storm passing through, it prompts a small, eerie humility. The glow of the northern lights is lovely, but it is also a signal. The sun has just reached down and touched us. We are guests within its reach. For all our ingenuity, we remain, in some ways, at the mercy of something ancient that neither knows nor cares for our plans. And still, life goes on beneath that star. Our species has learned how to watch and to adapt. We mended the grid after Quebec. We hardened spacecraft. We issued warnings that saved lives and assets. The story of the sun is not simply a tale of terror. It is also a story of human response, of learning, engineering, cooperation. The question is how far we push that response and how much we invest in resilience before the next truly severe event arrives. So when you lie in bed tonight and think about the sun, let those images come not as pure fear, but as a measured, curious concern. Picture the glowing aurora, but also picture engineers rerouting power, astronauts retreating into shielded modules, airlines shifting their flight plans. Consider both the beauty of those lights and the sobering truth they hint at. Ask yourself, if the next storm comes, will our systems hold? Are we paying attention to the quiet, patient star above that has the power to change the world with a single, invisible breath? The sun has always been unpredictable in its own way. We have learned to read it, to respond, and to adapt. We cannot stop it. We can only prepare and remember that our civilization, for all its strength and speed, still depends on a star that sometimes remembers. It can roar. The sun feels eternal. It rises faithfully, day after day, year after year. It has warmed the earth for all of human history, for all of life's history. And it feels impossible to imagine a world without it. Yet eternity is an illusion. Even stars have lifespans. Even the sun must one day change, grow old, and die. At its core, the sun is a nuclear furnace. Deep within, hydrogen atoms fuse into helium, releasing energy that slowly makes its way to the surface and out into space. That process has fueled the sun for more than 4.5 billion years. It is efficient, steady, and unimaginably powerful. But it is not endless. The sun's fuel is finite, and with each passing second, it burns just a little more of it away. Have you ever wondered how much longer this balance can hold? How many more sunrises are left in the sun's future? The answer is measured in billions of years, which sounds like forever to us. But in the story of the universe, it is only a chapter. And that chapter is already moving toward its next phase. Over time, the sun grows brighter. Slowly, steadily, almost imperceptibly, its output increases. In 1 billion years or so, Earth will feel the change. The oceans may begin to evaporate, their waters rising into the sky as steam. The air may thicken and grow heavy, heat pressing down until forests wither and deserts spread. What would Earth look like then? Would there still be life clinging to shadows, hiding underground, or deep beneath the seas? Or would the planet fall silent, a scorched and empty world beneath an unforgiving sky? And this is only the beginning. Fast forward billions more years, and the sun's fate becomes even more dramatic. When its hydrogen runs low, the core will contract and heat, while the outer layers expand outward. The sun will swell into what astronomers call a red giant. Imagine looking up into the sky and seeing not a small golden circle, but a massive red star dominating half the heavens. How would it feel to live under a sky where the sun was no longer gentle, but monstrous, swollen and burning? Would it inspire awe or dread? Mercury will be the first to vanish, swallowed whole by the expanding sun. Venus will follow, And Earth? That is the question. Some scientists believe the Earth will be consumed entirely, engulfed in the sun's fiery outer layers. Others think it may just escape, left as a scorched husk circling a dying star. Either way, our world will not be what it is now. Could anything survive then? Could humanity, if it still exists, watch from afar as their ancient home is destroyed? If Earth does survive the sun's expansion, it will not be the world we know. The seas will be gone, boiled away. The air will be stripped. The ground will be cracked and barren. Could we ever return to such a place, or would it only be a memory, a cradle long abandoned? And the sun's transformation does not stop there. After its time as a red giant, it will shed its outer layers, releasing them into space like a glowing veil. For a short while, the solar system will be draped in a luminous cloud, a planetary nebula shimmering in the dark. At its center, the sun will shrink into a white dwarf, a small, dense remnant, no longer fusing atoms, but still glowing faintly with heat left behind. Imagine a star no bigger than Earth, yet holding the mass of the sun, shining weakly as a pale ember. Over billions more years, even that glow will fade. The sun will cool, dim, and eventually vanish into darkness. A black dwarf, cold and silent, will remain where once there was fire. Will anyone be there to see that final ember fade? Will any record of Earth, of humanity, of life, still exist when the sun has gone dark? These are not questions of imagination alone. They are the truths of stellar evolution. Stars are born. They shine. They grow. And they die. The sun is no different. To us, its light feels infinite. But in reality, it is only a moment in the life of the universe. What does that mean for us, who depend on it so completely? Does it make our days feel fragile or precious? Even before the sun reaches its red giant stage, its growing brightness will change Earth in profound ways. Subtle shifts in its output have shaped our planet before. Ice ages, warm periods, changes in rainfall, all tied in part to the sun's cycles. Could a future shift tip the balance beyond repair? Could it make Earth less hospitable even before the oceans vanish? And then there are possibilities we can't yet predict. Other stars, similar to ours, have surprised astronomers with bursts of energy, superflares, thousands of times more powerful than anything we have ever observed from the sun. Could our sun unleash one of these? If it did, what would happen to Earth? Could our atmosphere be damaged? Could our world be scarred beyond recognition in a single flash? The unsettling truth is that we don't know. We can measure. We can watch. We can model. But we cannot predict every twist in the sun's story. We live within its reach, vulnerable to both its storms and its eventual decline. And we can do nothing to change that. So what happens to us, to humanity, in this story? Do we wait for the inevitable? Or do we move beyond Earth, beyond this sun, reaching for other stars? Could we build new homes under new skies, carrying the memory of this star with us? Or will we fade with it, our story ending as the sun's story ends? What if one day, far in the future, our descendants stand beneath the light of another sun, looking back across the stars at this one? What will they remember? Will they tell stories of a blue planet warmed by a golden star, of oceans and forests and skies filled with life? Will they whisper of the sun as a lost homeland, a cradle of humanity now gone? The sun's eventual death is not only a warning, it is also a reminder that nothing is permanent, not even stars. It tells us to value what we have now, each sunrise, each afternoon, each sunset. It tells us that our time beneath its light is fleeting and therefore precious. So as you think of the sun, think not only of its dangers, its storms, its future. Think also of its gift. It is because of the sun that you breathe, that you eat, that you live. It is because of the sun that Earth is green and blue, filled with rivers and forests and life. The same star that will one day destroy us is the star that made us possible. That dual truth is not meant to frighten, but to inspire. The sun will not last forever. Neither will Earth. Neither will we. But perhaps, knowing this, we can live more fully, love more deeply, and prepare more wisely. Perhaps, in facing the sun's dark truths, we find strength in our own small light, the light of curiosity, of imagination, of resilience. So the question remains, when the sun grows old and the sky turns red, where will humanity be? Watching from afar, searching for new homes, or gone, like so many species before us, our story erased in the fire of a dying star? The answers are unknown. The questions remain. And as long as the sun burns, we will keep asking them. We are, in the simplest sense, children of the sun. Every thread of life on this planet leads back to its light. The food on your plate began with energy from the sun, captured by leaves, transformed into sugars, passed along from plant to animal, to you. The air you breathe, oxygen itself, exists because ancient plants, fueled by sunlight, released it into the skies. Even the rhythm of rain and rivers is tied to the sun's warmth, which lifts water into clouds and sets it falling again. Have you ever thought about that connection? That when you feel the sun on your face, you are touched not only by light, but by the very force that shaped your lungs, your breath, your heartbeat. Could it be that we carry the sun within us, not just as warmth, but as life itself? And yet, with every gift it gives, the sun binds us to it completely. Without its heat, Earth would freeze into silence. Without its light, photosynthesis would cease. Plants would wither. Animals would starve. And the oceans would lock beneath sheets of ice. Could life last even a single week without the sun? Could humanity survive if its light dimmed, even for a short while? It is easy to trust the sun. We have no memory of a day without it. But is that trust misplaced? The balance we live in is far thinner than we admit. A slight shift in its warmth, a sudden storm, a flare too strong. Any of these could remind us how fragile our world truly is. How many times have we taken a sunrise for granted, not realizing what a delicate miracle it really is? Think of the civilization we have built. Vast cities glowing with electricity, planes crossing oceans guided by satellites, hospitals filled with machines that keep people alive. The financial systems, communication networks, supply chains, all of it is tied together by invisible signals and flows of energy. And what powers those systems at their root? The sun. And what threatens them most? The sun again. Isn't it strange, unsettling even, that the very star we rely on could also undo everything we have created? Imagine waking up to a world gone quiet. No internet, no electricity, no satellites humming overhead, planes grounded, trains halted, cities dark, banks without records, governments without connection, hospitals cut off. Would you know how to find food without supply chains? How to keep warm without power? Could our society endure in such silence? Or would it crumble, not from war or famine, but from the sudden reminder that all along we lived at the mercy of the sun? This is why scientists keep their eyes fixed on it. Satellites orbit, cameras watching every flicker, every flare. Instruments measure magnetic fields and solar winds. Warnings are sent when a storm is brewing. But even with all this vigilance, can we really protect ourselves? What if a storm arrived too fast, too strong, too sudden? Could we shield every satellite, every grid, every city? Or would the star we depend on remind us in an instant of how little control we have? And beyond storms lies the slower, longer truth. The sun will not always be kind. Its growing brightness will one day transform Earth into a place where seas dry and skies collapse. What happens then? Will humanity still be here, trying to endure? Or will we have already reached beyond Earth's cradle? Could we leave this world, traveling to other planets, circling other stars? If so, how would we choose? Would we search for another sun, familiar and steady? Or would we carry with us the caution of knowing how dangerous a star can be? Already, we imagine such futures. Telescopes peer into distant space, hunting for planets bathed in the glow of other suns. Probes test the limits of our reach, leaving the solar system, whispering back messages from the edge of the void. Could it be that the sun's greatest lesson is not only about survival here, but about inspiring us to leave, to prepare for the day when we must? But even if we go, will we ever truly leave the sun behind? Could another star ever feel the same, after all the millennia of life shaped beneath this one? Will our descendants, wandering the galaxy, still whisper stories of the first star, the one that gave them breath, oceans, forests, and dreams? Will the sun live on, not in fire, but in memory? Perhaps this is its most important gift. The sun is not just a source of light. It is also our teacher. It teaches humility, reminding us that we are small in the face of storms. It teaches fragility, reminding us that life depends on the narrowest of balances. And it teaches wonder, reminding us that even danger can be beautiful. But most of all, it teaches us to look forward, to prepare, to imagine, to dream of futures beyond this single star. What if we succeed? What if one day we harness fusion, the very fire of the sun here on Earth, creating an endless supply of energy? What if we leave our solar system, spreading into the galaxy, carrying life to places that have never known it? Could the sun's dark truths, instead of ending us, become the spark that drives us to endure forever? And yet, what if we fail? What if storms grow stronger, climates shift beyond control, or the sun's changes outpace our progress? Could humanity vanish, erased by the same star that gave us everything? Every answer leads to new questions. Every question reveals more mystery. That is the strange beauty of the sun. It is not only the fire above us, but also the mirror of our own journey. fragile, bright, fleeting. The sun will not last forever. Neither will Earth. Neither will we. But perhaps, because of that truth, we will learn to live more fully now, to cherish each dawn, to prepare for what lies ahead, to endure even when the fire turns against us. For now, though, we remain here, dependent, vulnerable, but alive. The sun still rises. The sun still sets. The sun still gives. And though its dark truths linger like shadows at the edge of light, its glow still holds us. But the questions remain, and they are worth carrying. What happens if its storms grow stronger? What happens when its heat grows too great? What happens when the balance shifts for good? Will we endure? Will we escape? Will we remember? Or will the sun, in the end, erase the very story it began? The story of the sun is vast. Storms and flares, futures and endings, gifts and dangers. Yet here we are tonight, beneath its quiet absence, held by the soft cloak of night. The sun still burns beyond the horizon, steady as it has been for billions of years. The skies are calm. The earth still turns. The seas still breathe. Does knowing the sun's darker truths change how you feel beneath its light? When its warmth touches your skin, will you think only of comfort? Or will you also wonder what storms stir within it? When you see it set, coloring the sky in shades of gold and crimson, will you think only of beauty? Or will you remember that one day that same fire could consume the world? The sun is both friend and threat, both gift and danger. That paradox makes each sunrise feel more precious. Every morning is not just routine. It is fragile, fleeting, a gift repeated, but never guaranteed. How many more dawns will Earth know? How long will this balance last? These are questions we cannot answer, but they remind us to treasure what we have now. So, as you rest tonight, let those questions drift through you, not as fear, but as wonder. What if tomorrow the sun unleashed a storm that changed everything? What if, millions of years from now, descendants of humanity told stories of a star that once shone on Earth? What if this very breath, this quiet moment, is part of a balance as delicate as the edge of fire? Do not let the thought trouble you. Let it soothe you. For the truth is that tonight the sun is still steady. It will rise again. Its warmth will still touch oceans and forests, cities and fields. It will still light the sky you wake to. It may one day destroy, But tonight, it sustains. Tonight, it guards. Close your eyes and imagine it, not as a storm, not as a threat, but as a silent guardian, waiting beyond the horizon. Imagine its light spreading gently across seas, mountains, deserts, and forests. Imagine the warmth that cradles the earth, the same warmth that cradles you now. One day it will fade, yes, but not tonight, not tomorrow. For now, it remains faithful and patient. And so, the final questions linger. What secrets does the sun still keep? What mysteries will it reveal centuries from now? Will humanity still be here to witness them? Or will others, somewhere far away, live beneath its glow? Could the sun's story be even larger than we dare to dream? Let those thoughts soften now, becoming whispers fading into the night. You don't need answers tonight. You need only peace. The peace of knowing the sun still burns, steady and strong. The peace of knowing it will rise again, just as it always has. The peace of knowing you are part of something ancient and vast, something both fragile and eternal. Rest now. Breathe deeply. Let sleep come. The sun is still above you, unseen but constant. It will rise again, and when it does, it will remind you once more that you are alive in its light. Dream now beneath the quiet truth that the sun, with all its mysteries, still shines steady and bright.